last day, we looked at what a power was, what are exponents. Then we looked at how do you get a number, how do you evaluate the exponent, and we looked at what happens if you have more than one power term, if they're multiplying and they're dividing, how do you simplify that? So today, the first thing we're going to go over here is what happens if you have exponent raised to another exponent. So these math questions come in all different formats, right? So the first question looks like, what happens if we had, say, 5 cubed to the 4th? Actually, I should do the same question I have on the board. Maybe let's go 3 to the... No, I'm going to do something smaller. Okay, what happens if we have 3 squared raised to an exponent of 3, right? How do we simplify this? Okay. Before going to the answer, what does this mean? Okay, the stuff inside the bracket means that we have 2 3s being multiplied to each other, right? And we still have a cube out here. What does that cube outside means? We have 3 of whatever it's associated with. We have 3 of those, right? So that 3 cubed means that we have 3 of these. Right? That's what it means. Right? So altogether, how many 3's do we have? 6. The simplified form for this would be 3 to the exponent 6. Okay? How do we jump from that step without having to do everything in between? Look at the exponents. How would you compare this exponent to over here? Right? How do you get used at 2 and 3? Do you add them, subtract them, multiply them, divide them? Christina.
You multiply them.
You multiply them. Okay? So the rule is if you have an exponent or power raised to another exponent, we simply multiply them. So, Levi, take out your notes. Right? You multiply them. Right? And it doesn't matter if the expression is a number power raised to an exponent or if it's a variable, like shown here. Okay, okay, so now, I don't like this next one. I'll just be honest with you guys. Okay, I'm going to do it because the textbook does it, but then I'll say my bit about it because it's not how I do math. When product is raised to an exponent, you can rewrite each number in with the same exponent. In the product, when we use the word product, it means we're multiplying the terms. That's what product means, right? With the same exponent. So if you have 2 numbers being multiplied inside of a bracket, then you have a raised to an exponent, you can take that exponent and distribute it amongst the 2 different terms inside the brackets. That only works if they're multiplying or dividing, right? But this is where I hesitate. So sometimes in math they make you do these kind of things because maybe in grade 11 you need to apply some sort of strategy which requires this. But in general, especially when you're working in grade 9, is what do we do when we have brackets? Like, right? You guys learned about bed mass last year, right? We clean up the brackets first, then We go bed mass, B brackets, then exponents, right? Then we apply the exponents. So this is not incorrect. This strategy can come into play later on. But in general, the way we apply math, we probably wouldn't go down this route. What we would do is we go 5 times 6, which is 30, 30 raised to exponent 3. That would be our simplified expression. Now, the textbook, for some reason, and other reasons, which I won't get into, so it may ask you to write it as 2 different powers. So that's what you have to do, okay? Just expose you to different things. All right. Now, the same thing applies when you use quotients. When I say quotient, that means dividing, right? So when a quotient is raised to an exponent, you can rewrite each number in the quotient with the same exponent, right? So you can take the 4 outside of the brackets and apply to everything that you see inside. So you end up being 5 to the exponent 4 divided by 3 to the exponent 4. Pretty straightforward, right? Okay. So in example 1, if we wanted to simplify this expression here, how would we write that as a single power? Right? You have to look at it. Is it multiplying? 2 terms multiplying? Is it 2 terms dividing? Is it exponent raised to exponent? And apply the rule. Can't see? Theo?
You would multiply the exponents?
You multiply the exponents. You have an exponent raised to exponent. It's ugly because we have lots of different brackets going on there. But we have this term here, negative 3 to the 4, and the square brackets and another 3 raised to it. So you have an exponent raised to another exponent, and the rule is you multiply those together, right? So we end up with 4 times 3, which is 12. And we keep the base the way it was. Don't have your notes, Andrew? Oh, no, Andrew, sorry, Levi. Back in here. Right? I'll give you a brand new one. We are on day 3. Sorry, what's it? Alright, you gotta get in a habit. Right now you're lucky I have extra copies. What I say typically to students is if you run out, I'll give you some blank paper. You can write these out on blank paper. Alright, so keep it on handy. So the next part is evaluate. Evaluate, give me the number. What is the number? Right? Joey?
531,441.
431. Right? So this is just being able to use your calculator. Right? You punch it in. Negative 3 raised to the exponent 12. And there you go. Right? Now, question B here, write this expression here as two powers. All right, close that door a little bit because that is loud. That is loud. Okay. What do we do? Which rule do we apply? How do we write this as two powers? Right? Look up. What do we do? Look over here. How did this 3 get distributed among the brackets? Right? It's a product. You apply to every single term inside the brackets. Right? So what would this be? We take this 2, and what do we do with it? Andrew? Do you know what to do?
You make each 5
Yeah. So this 2 goes to everything. So you rewrite it as 5 to the exponent 2 times 4 to the exponent 2. All right? So that's this expression written as 2 powers. All right? First power is 5 squared. Second power is 4 squared. If I said write this as an expression as 1 power, what would it be? If I said write this as 1 power. Joey?
20 to the power of 2.
20 to the power of 2. You clean up the brackets. 5 times 4 as 1 power. 20. 5 times 4 is 20 to the power 2. To the exponent 2. Right? Now, it says evaluate. So I want you to evaluate this on your calculator. 5 squared times 4 squared, and also do 20 squared. See if you end up with the same number. You should. If the math is right, both things should give you the same number. All right? Give it a try on your calculators. And you end up with the same number. Andrew?
I lack a calculator.
You lack a calculator. Jackie.
The answer is 400 for both.
Answer is 400 for both. Right? So let's go 20 squared, right, which is 400. We have 5 squared times 4 squared, so it's 25 times 16, which is 400, right? Should end up with the same answer. Okay. Oh, come on. Oh, where are you? There we go. Okay, write C as 2 powers. So you take the exponent outside the brackets and you bring it in. We're doing our notes here. All right? And you bring it in. Right? So what would the expression look like? Jessica, would you know? Jessica, right? Yeah.
3 to the exponent 3 and 5 to the exponent 3.
Yeah. The 3 just comes in. Great. Then you evaluate. Evaluate, what are the numbers? So clean up the top. 2 to the exponent 3. 2 to the power 3. It should be exponent 3. I'm using it wrong. What is that number? 2 times 2 times 2, which is 8. And 5 cubed, Theo?
125.
125. And you'll get to a point where you start recognizing some of these numbers because you use them over again. 2 cubed, 5 cubed, right? And it makes it easier. Like one of the homework questions was, you're given the number 125, write that as an exponent. You're like, oh, well, what will I do, right? Right? Well, one of the questions out of the textbook, right? But eventually you get a sense of the numbers the more you work with them. Okay. And this rule came up yesterday. We didn't explicitly talk about it. What happens if your power, your exponent, is 0? You guys remember that? If you have an exponent of 0, we sort of talked about it informally yesterday. What does that mean? If you have an exponent of 0, if you evaluate it, right? Nobody remembers? Joey?
If you do 0 as an exponent, the answer is always 1.
The answer is always 1, right? So that is one piece of information that you have to memorize, or you can always double check using your calculator. Stick in a number, put an exponent 0, it'll give you 1. Right? Now this works for all numbers except for when the base is 0. It doesn't work for the base 0. So that rule only applies if the base is not 0. Okay? That's what this little statement here is. This rule works except for if a is not equal to 0. or the base is not equal to 0. That's what that's saying. Okay. So example 2a, negative 5 raised to the exponent 0. What would that equal? Joey?
1.
B. Joey?
Negative 1.
Negative 1. You guys see that? Right?
So hard.
You remember that this exponent only applies to what it's attached to. So this is actually negative 1 times 5 to the 0. That's how you read it in your head. Negative 1. So 5 to the 0 is 1. So we end up with negative 1 times 1, which is negative 1. Okay? Excellent. So what if we have C on the reverse side? We have 5 in brackets raised to the exponent 0 with a negative outside the brackets. What would this equal? What would this equal? Theo?
Negative 1.
Negative 1. So this 0 applies to the 5, whatever it's attached to. So we have negative 1 times 5 to the 0. If you remember, you bring the 0 from outside the brackets to in, which ends up being negative 1 times 1, which is negative 1. Okay? And the final question, which I think was similar to the first question, 5 raised to the exponent 0. What would that be? Jackie? 1. 1? Okay. All right, so the last question for the first half of our notes, and I think this is the trickiest one, just because it's a different kind of question than what you've been used to, right? It says, write the 3 different products. Each product must be made of 2 powers, and it must equal 6 to the exponent 8. Whoa, what is that even saying? Right? It's saying that we want our 2 powers, our 2 exponents, when multiplied together, that's where the word product means, equals 6 to the 8. So before we even write out what these powers are, what must the basis be? 6, right? We want the base to be the same base as this. So we know this is 6. Right? Now, what could the exponents be? How do we determine the exponents? What we want is when we multiply these 2 terms together to have an exponent of 8. So what's the rules for when we multiply exponents? How do we deal with them? Do we add them, subtract them, multiply them, divide them? Serenity?
Add them.
Add them. So what numbers can we put here so it adds to the number we want? Scarlett. 4. We could put 4 and 4. Does anybody have another suggestion? Serenity?
3 and 5.
3 and 5. Does anybody have another suggestion? Joey?
6 and 2.
6 and 2. Right, so the question asked for 3. That's 3 different combinations. Is there any? Does anybody have another one? There's more. Andrew? Just scratching? Scarlett?
1 and 7.
1 and 7. Any other? There are still others. I came up with 5. Andrew?
Nothing and 8.
Nothing and 8. In other words, 0 and 8. Right? So the question only asked for 3. You just got to come up with 3. But those are all the different combinations. You just got to kind of break down what the question is asking you to do. And then say, this is kind of overwhelming at the beginning. Then you go, okay, just asking for 2 numbers that add to 8. Then you just figure out and you can go from there. All right. So that is